Assalamualaikum warahmatullahi ta'ala wabarakatuh, and hi everyone, how are you? So in this video, I will discuss the solution for Ujian Selaras 2 for question number 1 to 5 or topic 1 to 5, Physics SP015, 2023 and 2024 session. And the topic that relate to this discussion is dimension, linear and projectile motion, impulse and momentum, work done, power, and lastly, horizontal circular motion. For question 1, a force F is given by F is equal to AT plus BT square, where T is time, A and B is constant. Find the dimension of A. Firstly, before we go to the solution, I just want to recall back what you have learned before, especially about the dimension equation. Let's say if you have the equation, physics equation of A equal to B plus C minus D. So the way we write down the dimension is for the additional and subtraction operation. The way we write down the dimension equation is the dimension A is equal to the dimension B equal to the dimension C and equal to dimension D. But for the multiply and division operation, if you have the equation of such as A is equal to BC over D, the way we write down the dimension equation is dimension A is equal to dimension B times dimension C divided by dimension D. So that's the way how we write down the dimension equation from the physics equation given to you. And just to recall back, the dimension that represent the physical quantity, where M represent by capital letters of M, length, capital letters of L, and time, the capital letters of T. So now take a look at the solution. Given the equation of F is equal to AT plus BT square. So how you write down the dimension equation? Because of this is the additional operation, so we can write down that the dimension for F is equal to dimension for A times dimension for T equal to dimension for B times dimension for T square. Because we want to find the dimension of A, so we can take a part of the equation, the relationship, which is F is equal to dimension A times dimension T. We know the dimension F, which is force, is mLT minus 2. Dimension T, which is time, is capital letters of T. So you can calculate the dimension of A. It is equal to mLT minus 3. For question 2a, figure shows the velocity times graph of the motion for a particle moving in a straight line. Determine the acceleration of the particle for the whole journey. Firstly, take a look at the graph. From the graph V versus T, if you want to calculate the acceleration, it is equal to gradient of the graph. To calculate the gradient of this graph, you need to calculate the gradient path by path, meaning that firstly, you need to calculate the acceleration from 0 to 3 seconds. If you refer to the graph, you will get that the acceleration from 0 to 3 seconds is which is gradient of the graph is equal to 1.67 meter per second minus 2. And then the second part of the acceleration is from 3 to 7 seconds. And if you calculate the gradient of the graph, you will get that the acceleration is negative 2.25 meter per second minus 2. Question 2b. An arrow is launched with a velocity 23 meter per second and an angle of 30 degrees to the horizontal from the roof of the building of height 40 meter. So referring to the question, you can list the information given. Firstly, from the information given, before you solve the question, you can identify the hidden information where we get the value of u and theta, so you can calculate the ux and uy. Secondly, if you look at here, Sy is equal to negative 40 meter. So how we get Sy is equal to negative 40 meter? Referring to the height of the building. Okay, take a look at the diagram. If we define the displacement, which is from initial to final point in the straight line, so we resolve the s at the x component, we get sx to the right and Sy is downward. Because of that, our Sy is actually negative 40 meter. Now, you need to determine the maximum height reached by the arrow from the ground. So, for at the maximum height, what is the hidden info that you get from at the maximum height? So, here is h, which is represent the height of the building, well known, which is 40 meter. And you need to calculate the h prime. But we know that at the maximum height, Vy is equal to 0. Vx is still equal to ux, okay, for the projectile motion. To calculate, because we know the Vy and we want to calculate the h prime, So we can use the equation of Vy square equal to Uy square plus 2ASY. And then Vy, our Vy at maximum height is equal to 0. Uy that we have calculated earlier, 11.5 square minus with 2g and h prime. Because of that, if you calculate, you will get that the h prime is 6.74 meter. The question on you to calculate the maximum height, of course you need to add with the height of the building, 40 meter. So you will get that the maximum height is 46.74 meter. Okay. So question 2, you need to determine the time taken for it to hit the ground. So how long that the arrow take to before it hit the ground. So you want to find the time taken. To calculate the time taken, of course you need to understand what you want to calculate, which is t. So we use the equation, this equation. And when you substitute, take a look at the sy. We substitute sy is negative 40 because of the direction of sy is downward. And then uy is 11.5. And then a is negative 9.81. So when you calculate, you will get two value for t, which is the first value is positive 4.26 second, and the second one is negative 1.92 second. So we just take the positive value for t. That's the answer. And for question number 3, you need to calculate the horizontal distance travel. So horizontal distance travel is represented sx. Okay, the x component of the displacement. Sx, the equation is only equal to uxt. Our ux here is 19.92, and the t that we have calculated into, you just need to substitute in the equation. You will get that the horizontal distance travel is equal to 84.85 meter. Question 3a. Figure shows a graph of retarding force F on a car varies with time t when the brake is applied. Calculate the change in momentum. So this question, it is a few hidden information beside the question. Firstly, referring to the graph given, F versus T, we know that from the area under the graph of F versus T, you will get the impulse. But the question on you to calculate the change in momentum. Because of that, from the impulse-momentum theorem, we can calculate the change in momentum as area under the graph. So you just substitute where the graph is the triangle shape. So the area under the graph is equal to 1.5 times 10 power 4 kilogram meter per second or Newton second, represent the change in momentum. Question 3b. An object of mass 400 kg moves at a speed of 300 meter per second to the right. It's break up into two parts, one having a mass of 50 kg moving at a speed of 120 meter per second in the opposite direction. Determine the magnitude and direction of the velocity for the second part. Referring to the question, there are two hidden information here. The first one is V1 is equal to negative 120 meter per second because of object 1 moving in the opposite direction. And then the first object, when it is break into two parts, the mass is 50 kg. Of course, the second mass is 350 kg. We want to determine the magnitude and direction of the velocity. For the second part, we will use the principle of conservation of linear momentum. Referring to the principle of conservation of linear momentum, mu is equal to m1v1 plus m2v2 at the x component. And when we substitute, okay, if you refer to the substitution, make sure that V1 you substitute negative 120. When you calculate, you will get that V2 is equal to 360 meter per second. Don't forget the direction. So because of the V2 is positive, the direction is to the right. Question 3c. Figure shows a block has a mass of 8 kg, lies on a smooth frictionless plane till at an angle of 23 to the horizontal. Firstly, you need to sketch a free body diagram which show all forces act on the block. So to sketch the free body diagram, firstly you need to assume that the inclined plane is one of the reference line, our reference line, and the object is a point object. Now, referring to the object that located on the smooth inclined plane, so there is a normal force exerted perpendicular to the surface and also the weight of the object. Question number 2, you need to determine the acceleration of the block as it slides down the plane. So to calculate the acceleration of the block, first, because of acceleration is located at the x component, so we will use Newton's second law of motion, which is sum of forces at the x component is equal to ma. And if you look at here, W is not at the x or y component, so we need to resolve W into x, which is represent Wx, and Wy component. And Wx is located at the x component, so our Wx is actually mg sine theta equal to ma. And you can substitute in the equation where m is 8, g is 9.81, theta is 23, m is 8. So you will get that the A is equal to 3.83 meter per second minus 2. The third part, if the block start from rest 12 meter from point A to point B, by using linear motion equation, calculate the block speed when it reach the bottom of the inclined plane. So we need to calculate the speed when it reach the bottom using the linear motion equation. Because of that, we choose equation v square equal to u square plus 2as, and our initial velocity is 0. We just substitute, and then our acceleration that we have calculated into where the value is 3.83 and the displacement is 12 meter. So you will get that the speed when it reached the bottom is equal to 9.29 meter per second. Question 4a. Figure shows a box being pushed by a constant force F of 25 Newton at an angle of 30 degrees with the horizontal. The kinetic frictional force between the box and the floor is 10 Newton. How much total work is done if the box is pushed through a distance of 6 meters? Referring to the question, the equation for the total work is equal to F dot S or Fs cos theta. To calculate the total work done, you need to find the total forces exerted on the object, same component with the displacement. Because of that, of course, the free body diagram is important. From this free body diagram, you can identify that there are two forces at the x component, which is same component with the displacement. There are Fx and F. When you want to calculate the total forces, by considering x component, you will get that F cos theta for the Fx minus with F. And if you substitute the value, you will get that the total forces exerted on the object at the same component with the displacement is 11.65 Newton. Then, to calculate the total work done, substitute the value and do identify that theta is equal to 0 because of the angle between the total forces and S is 0. You will get that total work done is equal to 69.9 joule. Question 4b. A 2000 kilogram ball is released at the height of 10 meter from the ground. By using the principle of conservation of energy, determine the kinetic energy of the ball just before it hit the ground. Firstly, if you look at the diagram, if you want to calculate the kinetic energy before the ball hit the ground, you need to have the value for V, value for the ball before it hit the ground. But we do not have that value. Secondly, referring to the question, we need to use the principle of conservation of energy. Because of that, our solution will start with the principle of conservation of energy, where total initial energy is equal to total final energy. Initially, the ball consists potential energy U, and finally before it hit the ground, the potential energy change to the kinetic energy. Because of that, the kinetic energy is equal to mgh, and when you substitute, you will get that the final kinetic energy of the ball before, or the kinetic energy of the ball before it hit the ground is equal to 1.96 times 10 power of 5 joule. Question 4c. A 10 kilogram box is lifted through a vertical distance of 15 meter in 5 seconds with a constant velocity. Calculate the applied power to lift the box. Referring to the given information, and we know that we want to calculate the power, the related equation that we can use to calculate the applied power is P equal to FV. And then our F is equal to mg, and our V is equal to h per t. When you substitute the value for m, g, h and also t, you will get that the applied power to lift the box is equal to 294.3 watt. Question 5. Figure shows a 4 kilogram block is attached to a vertical rod by 2 strings. When the system rotates about the axis of the rod, the strings are extended as shown, and the tension in the upper string is 80 Newton. Calculate the tension in the lower string. Firstly, you need to sketch the free body diagram showing the tension in the string and also the weight of the block, and identify the motion of the block, where the block is moved in the circular path because of it is rotated at the axis of the rod. So the block is moving in the horizontal circular path. From this diagram, firstly calculate the theta, where theta is equal to shift sine 1 over 1.25. 1.25 is equal to the length of the string. So you will get theta is equal to 53.13 degree. And also referring to the diagram, to determine the tension in the lower string, you can identify or you can do the analysis at the y component, where at the y component, total forces exerted at the y component is equal to 0. And then here we know that T1y is upward, so T1y is positive. T2y and W2 is downward, so both of them are negative. When you substitute the value inside the equation, you will get that the T2 is equal to 30.95 Newton. For question B,